and see if
Well, maybe I can do it now because oh, okay.
we start recording and say hello, everybody, and welcome to the final quarter webinar for the American Statistical Association Statistical Computing section. I am super happy to introduce Claire McKay Bowen to give our talk today. Claire is a principal research associate in the Center for Labor, Human Services and Population, and leads the Statistical Methods Group at the Urban Institute. She primarily focuses on developing technical and policy solutions to safely expand access to confidential data that advances evidence-based policymaking. She's also got an interest in science communication and integrating data equity into the data privacy process. She was identified by the Committee of Presidents of Statistical Societies as an emergency leader in statistics. She's a member of the Census Scientific Advisory Committee, and also, and most importantly, the incoming president of the Statistical Computing section of the American Statistics Association. Yay! And today, she is going to talk to us about the art of data privacy. So Claire, please take it away.
Thank you so much for that great introduction. Yeah, apparently I just do too much is what I tell people, but I'm happy to serve the section and talk to all of you about my favorite topic, which is data privacy and confidentiality. And I call it the art of data privacy because I love to figure out clever ways to explain these complex topics, and I ended up using a famous piece of art to do so. So you'll see that in a moment. So I like to start off most talks, especially because this is more introductory. So if you have some background in data privacy, you might find this a little bit too basic, but I find that most people actually don't know about this important topic or how it affects federal, state, international levels of trying to share data. And so this is where we're going to start. It's like why you should care and how unlocking administrative data is really important for informing policy making. And so I like to start with this one example. This is an article that came out of the New York Times at the end of 2019. And it was talking about how we can use like simple pieces of information that can be very disclosive that you think are pretty innocent or really simple. So there was a data set that the New York Times took that only had Latin long and time. That was it. Only those three pieces of information. And they kind of walk through how you can figure out like where people live, where they work, and what kind of maybe extracurricular activities they do because of just exactly where they are located at what time. So you imagine sleeping hours. If you're in a residential area, that person lives in that location. If they're on campus of, let's say, Microsoft during working hours, they obviously work at Microsoft. And that's exactly what happened, is that they ended up tracking one person in particular and thought maybe we could figure out who they are. And so they were able to, because they changed their behavior in a unique way, which was they went to the Amazon campus for like one afternoon and then went back to the Microsoft campus. And then 2 months later, I think they started regularly going to the Amazon campus. And just knowing that behavior was just enough for them to then find that person on LinkedIn and correctly identify him. And so that seems a little invasive. Maybe some of you think like, wow, we shouldn't have access to this information, but this is exactly what we needed to combat COVID-19, right? Like this was published in December 2019, which is right before the pandemic hit, and everybody called for contact tracing. This information is also used, at least in the United States, to figure out emergency evacuation in case of, let's say, hurricanes or forest fires, which seems to be escalating over the most recent years. It's also being used for other ways too. And so I was hesitant to include this slide. I thought about removing it before today because given what happened recently, for those who don't know, in the United States, at the University of Nevada in Las Vegas, there was an active shooter and a few students died. And so some people are calling that like for this app that tells professors when students come into classrooms, if they're late, if they're on time, like when do they log into their assignments, which seems really invasive, but this technology could indicate when students are in a safe location where they need to go for these emergencies and to notify their loved ones if they are safe. And so these are just some examples, but why this matters now more than ever is that for other reasons, especially us as statisticians thinking with like more technical aspects or in our research area. First off is that the increase of data and computing power increases the risk of re-identifying individuals in survey and administrative data. So I'm kind of more focused on administrative data, but this very much applies to survey data, which goes into the fact that like, well, with all this additional information, with like social media, with our phones and other things, our ability to measure privacy risk has been growing rapidly. So the way I like to explain this to people is that if you ask everybody actually who's attending this webinar, how would you define what is risk or what is data privacy to you? We would all have very different answers because we all have a different sense of what is private information or confidential or what could be shared or not shared. And so going to the final point here, survey response rates are declining. I don't know about the other countries. I think a few of them have been seeing like a decline in response rates, but it's severely like been almost falling off a cliff in the United States. And so there's a lot of interest in using administrative data for research given such a huge decline in response rates. So again, kind of emphasizing the policy areas. I know that I've been focused more in the United States, but that's most of my experience. So we actually had an executive order back in 2021 on the first day of office from the Biden administration saying that we need to have also this kind of advancing racial equity for all, which requires us to have better access to data, or at least the collection of data, and being sensitive about the fact that some of these individuals that we are collecting information on, they're more identifiable. And so we need to think about their privacy. And then it's funny that earlier this year, he kind of doubled down on this, the Biden administration did, saying that we really do need to further this racial equity and support of these underserved communities. And again, this requires us to collect or at least give people access to data in a safe manner. And so that means that there's some interesting gaps that exist between the regulations and the practical realities that are going on. So in the United States, we have a dozen different, like we don't have one unified privacy law, we have dozens of them. We have like, there's HIPAA for health, there's Title 13 for census data, Title 26 for taxpayer, FERPA for students, CIPSI for other kinds of administrative federal data. You can go on and on. But then over in Europe, we have GDPR, which is used as a beacon of like ideally how we should think about sharing our information. And then CCPA here, apologies for all the acronyms, but CCPA is the California version. It's like sometimes referred to as GDPR light because it does mimic a lot of the features in GDPR. And so these are really important. And it's interesting that we actually have a lack of like consumer privacy laws in the United States, whereas in Europe, the data or consumer data is more heavily protected. So anyways, just highlighting that there are all these regulations that we all want to try to abide, but there isn't a clear way to translate this into technical methods that do exist. So part of it is because we do not define what do we mean by de-identification or what is minimal privacy risk. I mean, some of these laws say like there should be no risk at all, which is actually impossible if we think about the tension between privacy and the usefulness of data. If you want to have something that's perfectly private, then you just don't release anything. Right. So, but that's not very useful at all. Like we still need official statistics for a lot of our important decision making. And so we need to figure out exactly how we're, again, translating these laws into what is the reality. And then again, a lot of these regulations are very focused on the collection and then the dissemination. So to the point I was saying about like how like, well, we need to make no risk. And it's like, well, if there's no risk, then if that's a requirement, then we wouldn't release any information. And so then this requires a lot of interpretation, a lot of discussion, usually with lawyers, which is something I have to do with some of my projects, is like a lot of back and forth about lawyers saying like, well, we need this, and telling them like, well, that's not possible, or it's not feasible, or there has to be some relaxations in there. And then again, there's some examples if you want to check out further about this general call, especially in the United States, for better access to data in order for us to do a bit more evidence-based public policy making. So then you're wondering, okay, great, Claire, I'm motivated. I understand that this is really important. So, well, what have we been doing all this time? Like, how does one access data? And so here's some background on like what sometimes people are now calling like tiers of access to this information in order to do some of these decision making that is really important. So like the first way is just gating direct access to data, which is great, right? It's the actual data, it's unaltered, it's high quality, usually. Little asterisk on that one for obvious reasons. So anyways, usually the way we can gain access directly to the data is through like generally two ways. First is a data enclave. And so in the United States, we have federal statistical research data centers where you can go into the secure enclave, go to a certain terminal and get access to the data. NIH, which is the National Institute of Health, also has these kind of like supported data repositories that you have to make some agreements to in order for safe transfer of the data. I believe in Europe, in particular, University of Edinburgh has some data enclaves that they try to share, like the Scottish Longitudinal Survey, which is there's a lot of great privacy researchers over there who help support access to that. Going into the second way, which is using user agreements. So there's data use agreements, non-disclosure agreements, memorandum of understanding, like again, lots of legal lingo there, basically agreeing that how we get access to data, how it's going to be used, and how it's going to be shared, and ultimately also thinking about the termination of it. And so, again, wouldn't it just be great? In the idealized world, all trusted research and policymakers would have direct access to data. So why not give people access if they need it? Well, there's several hurdles, and again, I'm more focused on the US side, so just qualifying that there. There are these three big hurdles I see, but there's several others too, but I'm going to highlight these ones. The first one is eligibility requirements. So some of the administrative data in the United States can only be accessed by US citizens, which eliminates a huge portion of our researchers. I mean, a lot of our researchers are not US citizens. And so we are not unlocking the potential of like lots of great research that could benefit a lot of people here. And then the second one is a lengthy process. So I use myself as an example a lot. So here's my first one, which is saying that I have 5 different clearances, or at least I've gone through 5 clearances. I don't think 2 or 3 of them are active right now. And so it took the 5th time to finally just be automatically approved to get access to the data. It usually takes months or years to go through the clearance process. And if there's something like an emergency, like a global pandemic, you can't wait that long to access the data in order to do really important policy making. And then last one is that some of the data, like, okay, great, you're a US citizen, you got access, or you got through the clearance process, now you get access to the data. Well, some of these are, again, you go through a data enclave, and they could be hundreds of miles away. And so actually, I live, it is a place called Santa Fe, New Mexico, so not be confused with Mexico, it is a state in the United States, where Santa Fe is the state capital. So you would think, oh, well, state capital should have a data enclave. It does not. The closest one is actually in Boulder, Colorado. And so to give some scope there, that is over 400 miles, which now I got to convert that for, let me do that really quick. So if it's 400 miles, so that is 640 kilometers to go to the closest data center. So that's over that. So I would say estimate that to being over 650 kilometers away. So that's quite a bit. So that's actually not that equitable. One, it's like resource of my time to get to that location, having the support to do so, like staying maybe at a hotel, getting food, lodging, everything, right? So that's not at all equitable. Okay, so I kind of doom and gloomed on the direct access. Well, obviously other people get access to this information other ways. So the second way is like kind of querying your statistics, or asking kind of like the questions and then getting some sort of answer back. And so this is how I kind of think about, or try to explain to people about the access to data. So there's like these kind of 3 general layers where you have like the user who has these kind of analyses they want. Then there's the privacy expert like myself who says like, okay, these are the analyses that they want to do. And I work with the data curator, or the person who's responsible for the confidential data. And we work together to say like, okay, these are the things that people want answers to. Let's work together to figure out what are the specific statistics that come from the confidential data. Let's apply what's often called a statistical disclosure control or limitation method. So like a method of privacy and confidentiality. So we're altering the answers just slightly, just enough that it doesn't reveal too much sensitive information about individuals, but still get you the useful information you need to make your kind of decision making. And then we give some of the results. So usually when it is like this more interactive approach, you get the results as summary tables or statistics. And a lot of places kind of publish these massive tables on their website saying like, hey, here are the unemployment rates for these regions, or things like that, which seems to work out pretty well. It's really nice because it's a predefined system, so you can get table builders. The CDC, which is the Center for Disease Control in the United States, actually has a table for like certain health statistics, like mortality rates or birth rates. And it actually is an interactive table where you're like, oh, I want to know for this region, where are the rates, which is nice. There are things called validation or verification servers. So this is kind of these terms are not fully been agreed on in literature, so I'm going to define them really quick here. So a validation server is the idea is like you can submit some code like our code that can run an ordinary square model directly on the confidential data, and then you get an answer back that's noisy. So you're kind of like getting the validation of that data. Verification is similar, but you receive like a verification on like the statistic you want. Usually this is for both of these systems, they're paired up with a public data set that you can like test your code on. Let's say you do, again, like a square model, you get a coefficient. And so in a validation server setting, you would get the coefficient back that's slightly been altered. In a verification server, you know what the coefficient is on the public data, but you want to verify, does it have the same significance level or sign or the same sign? So that's what a verification server does. So that's one way to access the data if you don't have direct access, which can work out really well if you have a specific question you want answered, but sometimes it's just nice to see the data. So I already talked about how there is like these things called public data files or publishing the micro data. And so this is done very similar to that framework that I told you before, except for there's a little asterisk here on the analyses and the statistics, because you're trying to figure out like what are the features of the data we want to make sure we preserve once we generate this micro level or record level data set. And there's obvious trade-offs for this, and pros and cons is that, well, it's really nice because you do get like this, you get access to this data, you can finally see it. It's great. It's very familiar for data users. It's also easier to control what we call the privacy loss or disclosure risk, because you're just publishing one data set and that's it, versus like the more customizable or responsive like data, or excuse me, the table builders where people can query a bunch of different kind of questions. So it's kind of hard to track exactly like how somebody might attack that. Also, there's less infrastructure needs. So yeah, you just publish the data, make it clickable or downloadable through your website, or thinking about some of the data repositories that are out there. Those are easier ways to do it versus having to make like a dashboard with the table builder in it and make sure it's like user friendly and you work on all web browsers and things like that. So obviously there's some drawbacks. Because you're publishing just one data set and you're trying to highlight certain features, you're obviously going to miss a lot of other features too. And so it's hard to capture all the specific use cases. And usually you have to optimize the data onto one specific use case or a set of use cases, but still it's hard to do that. It's a less targeted process, again, like what I just mentioned, and it allows for further downstream privacy loss in case like you do multiple data sets, whereas like, let's say it's a periodic one, and so it's kind of hard to find like the accumulation of privacy loss over time with that. So that's not all the doom and gloom, but those are generally the ways that people kind of think about releasing data sets. This is why we have to think about tiered access and figure out like what are the needs of people versus like what are the privacy loss and risk, and like what fits with the regulations. And so then this goes into this other part here, which is like, well, what are kind of the methods that can be used in order to get, let's say, the noisy statistic or the noisy data set? And so this is where the piece of artwork comes in, because sometimes it's kind of hard to explain to people exactly like what you're trying to do. And I tell them that, what if this is the data set itself? You want people to get this idea of people in a park, that there's a lake, maybe there's trees and some grass, there's some dogs on the playground. There's also a monkey. I mean, Saurabh had some weird ideas about what is a pet here. So anyways, we're moving on. So what if you're just trying to highlight certain things that we don't need to know every single blade of grass or look at every part of the tree? And so one of the easiest ways to alter the data set in a way that can protect people is just suppression. It's just removing individuals. And that's very intuitive, right? If there's somebody who's super identifiable in the data set, you might want to remove them. And so I'm an Asian American, and I grew up in a very rural part of the United States. And when I say rural part, I mean, it is, let's see, the population was 3,000, and that was the biggest one in a large area. So I usually tell people it's the size of Connecticut is the county, and the city I was in, it was the biggest one, but Connecticut is not I'm trying to get some people from abroad thinking like how big that might be. I think it's like 4,000 square miles. So if you do, let's see, 4,000. Trying to do some conversion on the fly. So that's, let's say 6,500. About 6,500 square kilometers. So it's a pretty large space. And so I am definitely identifiable in that area of the United States. And so like, of course, like removing me from the data set would protect me because I'm not there. But the downside, of course, is that I'm not represented in the data. What if it's really important to know that there are Asian Americans in that area of the United States because of certain needs. For instance, in the United States, we found out that there was an inadequate or inequitable way of distributing vaccines when we actually had vaccines for COVID-19, and it was more negatively impact people of color. So another way to alter the data is generalization, or sometimes called aggregation. So instead of reporting down to like more specific subgroups, you can broaden the groups up, especially if you don't actually need to know exactly all the like fine-grained details of the population. You just need some like broader level information, like it could be by geography, or one of my favorite examples is to talk about education. So in the United States, you can get like GED, high school diploma, some college, associate's degree, and then so on and so forth. That's too much detail. Maybe you just need to know if like somebody has a high school equivalent, has some college, graduated with a bachelor's level, and so on, and then maybe just graduate degrees. Another thing is called top coding. So it's like similar to aggregation a bit. You're just trying to a mix, I guess, aggregation and suppression here in this case, thinking of ways that if some values are so extreme, it's hard to report, but you still want to say that there are some individuals in kind of that group. You can top code it. So a great example is age. There's not very few people who are over the age of 85. So if somebody is over 85, you just say that the 85 plus. That same thing for like what's called bottom coding, is just thinking of like less than something. So you can say like somebody's under 18. This is sampling. So in this case here, I took some of the pixels and randomly sampled which ones that got removed from the image here. And so for sampling, you can imagine that you can kind of do some like plausible deniability of whether or not someone's in the data or not, because you're like, oh, it's a sample. This actually started because it's really expensive to try to ask questions of every single person in a country or a region to answer questions. So you do some sort of sampling here. So here's like a zoomed up version for this image where I did it about like a 70% rate, just so that you guys still have an idea of what the image is. Typically, I believe a lot of the sample surveys, we know that they do like a rate of like that closer to like 10 or 20%. I say this, but I see Stas in the audience, and he's a survey statistician and I am not. So there's that. So anyways, moving on. So another way to protect data is adding some noise. And so there's some strategic ways to add the noise, but like one way is like thinking about if there's continuous values, let's say like income, you can add a little bit or subtract a little bit. And so in this case here for this image, I took all the pixels and randomly added or like lightened and darkened the image. So you can still get a sense of what the image is, but it's kind of like really fuzzy. And so it's just not super precise. And so maybe that's all you need from the data, is just this high level overview of knowing that there's some people, you don't know what they look like, but they are there, some in park, and it looks like there is a lake. Finally, thinking about synthetic data. So trying to figure out a model that reflects the statistical characteristics of data, and then you generate like pseudo or fake records based on that model. There's different ways you can do this. The way I kind of was showing this for this Seurat painting is that you just want to highlight the people, you want to fuzz out the background, and so that's what our model does, is just highlighting these individuals here, and then you don't need to know exactly like a number of trees or that there is a lake. You just know that there are these people here. Well, and then there's also the drawback for synthetic data generation, which is like figuring out like, did you pick a proper model? Is it too specific? Are you replicating too many of the original data, individuals in the original data or the confidential data? So there's all these other kind of tensions here. And so here, going back to our framework, so you can imagine as a privacy expert, I try to help think of like all these kind of analysis, the tension of the data users what they need, working with the data curator who says like, hey, this is what the law says. And so we're trying to figure out, okay, the context is like, this is park with a lake. There's some of the statistics could be people or the colors, the grass, there's trees, water, sky, so on and so forth. We can look at all the different methods and be like, okay, we don't like suppression or we don't like the data. Maybe we actually like generalization, where I realize I didn't explain how I made the representation for this raw painting, but here we go right now, which is saying, instead of saying like all these different shades of green or blue, we just picked one color blue, one color of green. And that's what happened here, where we're like, okay, this still gives us the image of being a park with a lake, guy idea of the people, don't need to know the specific color. So it works out well to at least people get an idea of the original painting. And so that's an example of doing the micro level data. I'm just going to go back to something I talked about earlier, which is like kind of the interactive, doing kind of like a validation server or table builder and things like that. So just going back into this, still the same kind of framework I'm showing, or we've been running with now. So it's very similar here, where instead hopefully it's interactive without somebody being more active. That's why the privacy expert is kind of removed here. It's where the user says, hey, this is the analysis I do. They go up into a terminal, they submit their analysis. It gets access to the original data, figure out what the statistics are. Some noise is usually added. And so making sure that it's the proper way of adding it, because you want people to still get the proper inference. So in this case, making sure the analysis is like, oh, is it upward trajectory versus a downward? And then you get some results to the data users. So with that, we're going to move on to the next part, which is, okay, Claire, awesome. You showed some great examples, but you kind of hinted at that we don't have really overall like an ultimate solution. And that's true. It's really actually hard to implement all these frameworks. First off, it's sometimes hard to make sure that you're identifying the proper groups and making sure that the representatives have a seat at the table, because you can't imagine that like every privacy expert and every data curator knows exactly all the needs, can contact all the data users to make sure the data and the statistics are properly representing the needs. And so that's really hard. And it's an ongoing problem on how do you properly engage with these individuals. It's also trying to figure out the disclosure risks and how you define usefulness. So people say like, hey, we need more use cases, but like one, how do you determine which one is like the maybe gold standard use case, or which set of use cases you should see? Or is it a case where that, again, going back to trying to find the proper groups to engage with, like what if one place is really noisy and so you're like, okay, we're going to use those use cases, and you don't hear from other groups because they just don't have the resources to inform the data curators or those who are in charge of the data exactly what the needs are. I think a good example is in the United States, New York City is a very loud voice. They have a lot of people who work on the analysis of the data, how to share it, and they will very loudly say, like, this is the statistics we need and this is what needs to happen. But what if you're in a more rural area of New York State? How is that person or those people's voices being heard? So that's, again, the tensions here. And then finally, communicating the constraints and limitations about these different methods. And so sometimes I hear people like saying like, hey, synthetic data is the future. This is how we should do things. Or I'm going to talk about in a moment differential privacy in a bit and just give you an overview of that approach. It's like, this is the right way to do it. It is the ultimate like answer to everything. And the answer is no, there is no silver bullet. There's too many things to consider. Like I already said, making sure that people's voices are properly heard. Are we defining disclosure risk properly? And also the usefulness of the data. And so because of some of these tensions, this is why people are kind of ushering in about differential privacy and what is privacy law. So I'm going to do a quick crash course of what is differential privacy and to give you guys a high level overview of this. So I'm not at all saying this is super extensive, but I'm just trying to give you like maybe 3 key takeaways about what is differential privacy and what is privacy loss budget. So the first thing is differential privacy is a definition actually of privacy, the maximal loss that can result from a publication or a statistic. It isn't a method. A method can satisfy differential privacy or be a differentially private method. And so this is a really important thing to stress here, because I often hear like, hey, we're going to use the method of differential privacy. And it's like, it's not method. It's again, a definition. You might hear some terms of like hearing formal privacy. That's like the bigger umbrella that people have now termed that differential privacy is a specific definition. There's other ones called zero concentrated, approximate. Now I'm like forgetting all the different kinds right now. There's like these different relaxations or versions but they all fall under a form of privacy. And again, they try to assume like the worst case scenario of how somebody or a record can be affected in the data. And that's why it is this very strict definition of the maximum privacy loss that can result in releasing information. So again, not going to go into the math of this, but if you're going to take anything away, here's one of the first things. The other thing is that differential privacy, unlike other kind of methods, or you're trying to find disclosure risk, is that it provides a knob that adjusts the trade-off between privacy and accuracy. And so I already said that there is an inherent tension and that there's an extreme of like, if you want ultimate privacy, then that means that you release no information. So then on the reverse of that is that, well, if you want something that's super accurate, then it's you just release the data unaltered or the statistics unaltered. So that's very, very accurate, but no privacy whatsoever. And so so those are the two extremes. And the way that we usually define privacy loss and trying to figure out something in between there is that we have to predict exactly how somebody's going to behave or a group of people are going to behave to attack the data, or like what tools do they have? Are they looking for one person? Are they looking for a set of people in the data set? Do they have a supercomputer? Do they have like proprietary data on their side to try to like analyze things, or are they going to use public data? So thinking about like the New York Times example, that's a really good one, because they were like, let's just go find one person, not one person in particular, but let's just look for that one person and use auxiliary information like social media on LinkedIn to figure out that person. So that's one way of attacking, but again, it's hard to predict exactly all these different ways. I'm stressing this because with differential privacy or formal privacy definitions, they assume the worst case scenario. So looking at number one, which means that you can get this knob, this what's sometimes called epsilon. There's other privacy parameters, but we use epsilon just for the general case to kind of figure out exactly how we adjust this. So I'm going to use another image to help kind of explain this. So again, I said the first extreme is like something that's really private is that not releasing information. So I'm showing you a blank screen here. You have no idea what I'm going to show you next. And so this is where an epsilon is equal to 0. You're not going to spend any, like say, budget or money to get to see any information. And so let's like increase it just a little bit. And so you spend maybe like a couple dollars and you're like, okay, I just kind of want a sense. So now you got some color in here. You kind of have a rough shape, but I guarantee most of you don't have any idea what this image is. And so we're going to increase it a little bit more and get some more finer resolution. Let's say I spend a few more dollars. You're like, okay, I get a better idea. But if you let epsilon run into infinity, like spending a bunch of money, then you're going to get the exact image here. And so this is what differential privacy allows you to do, which is something we didn't actually have with the previous kind of ways of defining disclosure risk. The other thing is that because you can quantify the privacy risk, you can figure out the composition or computing the total potential loss from multiple individual or releases of data publication statistics. And that was actually very hard also. Like I'm kind of hinting at this multiple times. The pathways of defining disclosure risk, it's really hard to quantify for a single release, let alone let's think of series of releases. So you can think of data sets that are periodically released like every year or every quarter. And so this gets really tricky. But if you use a formal privacy framework or something that uses like differential privacy, then you can actually quantify it. So here's like a very simple example. Let's say from this confidential data, I'm going to make 2 different public data sets, but it's sharing the same information. So like one of them, I'm going to spend 1 epsilon, the other one I would spend 2 epsilon. So the total privacy budget for this whole framework here is a total of 3. So that makes sense because we're touching the same part of the data. But let's say we make 2 disjoint parts of the data set. Like let's say it's like one part of the country versus the other part of the country. There's no records that overlap. And so even though we spend 1 epsilon on one data set and 2 on the other, the total loss should be just 2. So this is actually a nice feature. This called composition theorems that come under this formal privacy framework. So again, here's my crash course on explaining differential privacy and privacy loss to you, and kind of help explaining that it tried to address some of those earlier issues I covered, but then you can see that there are some others which I'll go into in a little bit. So going back to our little framework here. So a lot of people think that differential privacy or formal privacy is separate from statistical disclosure control. Technically, it falls under this bigger umbrella of like statistical data privacy. Like it's another tool in your toolbox to allow people to get access to summary tables and statistics or a microdata, but it's treated very differently because it's a different way of thinking about how we should protect the data. It's so different that a lot of times we just kind of say like, well, it's in parallel. And so we're going to talk about like differentially private synthetic data or differentially private summary tables and statistics. And so just kind of like thinking about it alongside the other methods, but knowing that it still falls under the larger umbrella. And so at least for me on my terminology, which you're hearing this a lot, is that we're not consistent in the literature, but I tend to call these other methods, the ones I described earlier with the Seurat painting, as more of the traditional statistical data privacy methods, and then formal privacy or differential privacy being a separate area, other area when discussing about ways we can access data. And so that was a crash course, a high level overview, hopefully like getting you motivated about why this is such an important area, why you should be concerned, how it affects everybody, and then some of the methods or ways to access data. But now you're maybe wondering like, what are some of like the future challenges or things to be considered? Or maybe you're like, hey, I really want to be a part of this field. Like, how can I contribute? So the first thing is communication and education. And I hinted at the fact that there is a huge downside to differential privacy and formal privacy methods. And the biggest one is that it's not very intuitive. I mean, I gave you a very high level overview, but we dug in deeper. It's still not easy to understand. And so it becomes a huge communication barrier to try to get people to like on board with these methods. And this kind of goes into some of the things we're seeing overall in the whole statistics field, is that as methods get more and more complicated, there's like a wider gap that we need to try to get people on board, let's say politicians, students, like others, to figure out how these methods work. And so we're trying to build like paving stones or a bridge to like close this gap, but that requires better communication, requires us to go more like further into trying to explain these methods. And so that's like a huge piece for the statistical data privacy field. And especially on the fact that let's take it back up here. So in order to communicate some of these ideas, people think about like, hey, there's my favorite blog, or here's a great book I recommend, or here's a video that helps explain all these methods. You should check these out. So if you were to be asked like by somebody like, hey, I'm interested in learning about machine learning, or now it's like, let's say AI, I bet you have your favorite video or blog, or thinking about like, oh, here's one for beginners, intermediate, advanced. Here's one for like an economist, a social scientist, demographer, things like that, right? Like I bet there's a lot of different resources, or at least you can know where to find them. That's not the case in statistical data privacy. There's very, very few books, videos, blog, all those other things. I bet you all would be more limited in trying to figure out how you recommend it, especially if you're thinking about like skill levels or different kind of backgrounds, trying to figure out what should be communicated. And so, or what communications materials you to use to help communicate with your colleagues. And so this is like, again, a big hurdle for me in the field. But part of it's because we lack the education for this as well. So one thing I tell people is like, there's very few of us are in the field. Like, I used to make the joke that like, you can shove us all in a closet and or a big one, but we all know each other. We're all like on a first name basis. We know who all the people, major players are. But that's not good, because this is such a big and important field. I mean, I am biased. I think it's big and important, but I think I communicate properly to all of you how it does impact everybody, but there's not enough of us who are in it. And part of it's because we don't teach statistical data privacy. Most of the time, if you learn about it in school, it's not until you're in graduate school, and it's usually in a computer science department. So they actually dominate the field. So I would say, like, I don't have the exact number, but it feels like there's 50 to 1 or maybe 100 to 1. So I'm saying like there's 50 to 100 computer scientists to 1 statistician that works in this field. And so because of that, the research agenda gets dictated by them. It's also the fact that like, well, they're the ones who teach it in their courses. So less of the other areas that are impacted that do research it, like statisticians, economists, I would say is next after statisticians. There's a lot of social scientists and demographers who are also interested in this area, but it's not taught at all at that level, even though we should be teaching it at the undergraduate level, because we're having a lot of students that are saying like, oh, I just get this beautiful, lovely data set, and that's the real data set. I can analyze it, get the results I want. It's totally fine. And then they come to the reality of like, they get census data or some other data sets from the government or from some other entity, and they don't realize it's been altered, and that's going to impact their analyses. So the other thing is thinking about then the human computational resources. So because we don't have enough communication materials to train people, because we don't have a good pipeline of people, we have a huge deficit in the number of individuals who are working in this area, and then therefore creating computational resources. So on the human element, usually I tell people, it's like, well, why don't you go on LinkedIn and just look up jobs that have the word privacy? So it's not the particular subfield I'm in, but just look at privacy in general. Last time I did this, there was like 170,000 jobs that use the word privacy in it. That ranges from like a privacy lawyer to somebody who does like cybersecurity and things like that. But it just shows that there's a huge call for this, and more people are aware of like cybersecurity or network security and things like that, and not thinking about this one area of like, how do we safely expand access to data, which is super important. And so because you don't have enough people to fill in these positions, that means you don't have them creating resources, in particular computational resources. So what I mean here is that sometimes you don't need somebody who is more mathematically inclined and knows like the nuts and bolts in order to apply the method. They just need to be like, hey, I have a statistic, I want to share it with my colleagues who are in a different area of the country, but there's some privacy rules, so I need to alter them. I just need to like download some code and just alter it. And so the analogy I like to use in this case is that you don't need to know how to build a bike in order to ride it. And so wouldn't it be great if we have a bunch of like packages that could implement these methods, but we really don't. There's actually very few out there because again, we don't have enough people programming these. Another area that I think is really important to highlight in particular is thinking about equity. And so that was in my bio introduction because I've been trying to get more into this space of like thinking about the equity considerations of the full data privacy process and gaining access to data. So there's this report I co-authored with a colleague, Joshua Snoke, about how do we think about equity in data privacy methods. And so we found that one, it's very sparse literature on it. It was like mostly only like in the last 5 years that has anything about even thinking about privacy or equity in data privacy methods, and that there's a lot, just like how there's so many different definitions of how we define privacy or usefulness of the data, there's so many different ways that we can think about equity in data privacy methods. And so one of the obvious ones I'm going to highlight here is that trying to think about like, what does equal utility and equal privacy loss mean? Because that's been the ultimate tension, but like, how do you define that for different groups? And there's different ways of doing it. And so actually when interviewing with Sesha about this, we talked about how for some of us, if we're in a data set, we don't care if people know that if we're female or if, like for me, Asian American, but if I'm in a data set with somebody else who is non-binary, then they very much care if people know about their gender. And so there's an equity issue in there. So, okay, so wrapping this talk up, so some concluding thoughts here. There is, oh, I do see a question. Well, I have to do the question right after this then, concluding thoughts. So obviously there is a need for data sharing, but there is a growing risks associated with that, right? We're obviously seeing this. But so in order to address these things, we need to have more effective communication, and I think education are going to be very key. So one thing you've heard me say, like, well, the literature has not settled on this term. So it's really much is that we need similar technical language. One of the things that some people ask me is that, like, if you had a magical wand to fix something in your field or solve, like, what would it be? My first response is us having a common language. Like, it would be great because we have computer scientists, statisticians, economists, social scientists, I mean, going on and on. We do not have a common language to discuss this field. And it drives me nuts because sometimes I read a paper, I'm like, do they actually mean that? Or do they mean something else? Like, one of the classic examples is that we all know what a marginal table is, or a cross, like a full cross tabulation. So computer scientists were calling them histograms in the papers. And I got really confused because I'm like, are they talking about a plot? So this is some of the issues that are happening is because we just don't have that common language. And so that also goes into, we as statisticians need to take more presence in the space, like through the research, through the teaching, and through the scientific communication. So because, like, again, I just said computer science is dominating the field. So this is actually something I discussed actually in a paper recently published in JASA about how computer scientists all said, hey, regressions are solved for doing differential privacy. It's completely solved. It turns out it's because it's solved for the prediction output. It's not solved for giving you a coefficient with standard errors. And so this is why it's really important for us to take a presence, to raise our voices and to be more active in this space, because otherwise what the research agenda ends up being, or what we get taught, or how things get communicated, is going to be dominated by others. So that's why I would like some people to think about how they would communicate this on undergraduate curriculum, at least like maybe at a minimum, maybe do like a seminar, maybe just tell them that this exists. I mean, I have a colleague who's really interested in trying to develop a full curriculum, so that way it's like modularized and other educators can just pick it up and add it to their course. But again, that takes time and energy, and there's not very many of us. So then going to like the last concluding thoughts, which is there is no methodological silver bullet. If somebody says like this method is the one that solves all, it's wrong. That's not the case. It's because, again, there's different needs, there's different situations that we need to consider, right? We need to think about like, what are the downstream uses? It could be very different. So maybe, yeah, synthetic data is the right way, or differential privacy is the right way to do it, but it's not going to be the one that will solve all. And so then we also have to be transparent about the benefits and limitations about being shared. One of the examples I give is that I talked to a colleague at NASA, and she did ask like, hey, how do I publish health statistics about astronauts who are at NASA? And I said, you can't protect them because you're required by law to publish them. And how do you protect the one female astronaut, right? So there's obviously limitations with that, and you have to think about those situations. So going into last few, focus on translating theory to application development. A lot of the field has been focused on theory, but not how do we apply it. I mean, I'm an applied statistician, and it's really hard. It is genuinely really hard to apply these methods. People say, well, just apply it, it'll be fine. It's like, data's not like that. Thinking about all these tensions is going to make it a lot trickier. And so this is why we need to have some focus on that, which goes into advocating for more funding for applied research and development. Again, creating those tools and educational resources I talked about, because we just don't have enough. And then concluding everything, that do not treat equity as a separate field of study. We actually have to think about it, not in the privacy sense, but also thinking about like how we collect or acquire data all the way to how we terminate it, because there are definitely equity considerations at all steps of that and how people interact with it. So that was a lot. I think I also talked a little fast because I always get way too excited and talk too fast. So hopefully you guys got what I was trying to say. And then I did see a question, so I'll try to answer that soon. But I'm going to say thank you so much. And then I see Giles is on now.
But I was going to say thank you, Claire, for a wonderful talk. That was super informative, at least for me. There is at least one question in the Q&A. Let me encourage anybody else to put their hand up or to put a question in the Q&A. The question was, are there recommendations about privacy methods for high dimensional data or data containing multiple sensitive variables? And let me sort of generalize that as, are there particular concerns that you have to be worried about when you're starting to think about high dimensional data and privacy?
Yeah, that's a great question. You do have to think about like all those different relationships and how you preserve them. I mean, I will say that one of the popular approaches if you're trying to release the data set with these lots of variables is people are thinking about sequential data synthesis, where you start with like maybe some base or starter variables that are like really key and important, and then you synthesize the rest of the variables based on that. So there's some tree-based models or cart models that you can do to do that. So again, this field is like, we still need more practical applications to kind of give lessons learned, but there's a few cases where there's like one based on German economic data, and then there was one from education data out of the University of Maryland, or for Maryland State in the United States, that showed that the sequential approach works pretty well. For one of my projects, we do that for taxpayer data. We found the sequential approach works pretty well, but the limitation is that you can imagine as the variables that get synthesized later in the process, there's going to be way more variability than from the start. And so you can see kind of this fan effect of like, as you go further out, variability is much higher, and that they're just not going to be as well preserved in the relationships among like certain variables. So this is why it's really key to figure out like, what is your starting data set? How you prioritize the ordering of things also impacts the quality of the data for certain things.
Here's a, well, let me go on. Could answer this one. do you have any decision charts or general resources to use with these with people who are asking, what should I do? This is from Alexandra Ruth. In terms of a discussion, right? So in a practical context, of somebody comes with you saying, okay, how do I deal with this? Is there a framework to start thinking about?
That's a great question. Again, like these are all good questions. Like where's a good starting point? Where's a good framework? I mean, I don't have like a one-stop shop source to like think about all these different methods that are all like sparsely pieced together. Like for instance, I have an intern working on some of the coding for synthesizing data. And I basically said, like, this paper you read first, and then this paper, and then this paper, and then another one, because it was like progressively gotten more technical. That there's not, I would say, like one-stop shop that I would recommend people to be like, hey, here's what you would do for this kind of data set. Here's what you do for another. I mean, that's actually some of the papers I would love to publish. So if there's one in particular, I would love to like create kind of like a matrix and be like, in these cases, for this kind of data set, you would apply these kind of methods or use this kind of utility metric to capture these other aspects. Like I would love to have those things, but there's just not enough of us. So usually I tell people like, come join me. I want to do all these cool things and maybe encourage you to do these cool things because I would love to have these resources. So, so there's that. I mean, I guess I see on the chat point, I have published a book that goes on overview. There is, I think it looks like Stas also linked into a paper by Jerry Ryder. So he did publish one about synthetic data. There's one from Ragu about synthetic data, and your Dressler, excuse me, not saying his last name correctly, about like that kind of the history and overview of synthetic data. I wrote one also with Monica Hu that goes like a full review of synthetic data and like the pros and cons of it. And then I also wrote one about formal privacy with a colleague too. So those could be starting points. So hopefully, maybe as a follow-up, you can share those links. And so that way some people have some resources. I know that wasn't satisfactory, but hopefully at least helps a little bit.
Well, and you have complained about a lack of these kinds of resources. And in fact, we have another couple of questions coming up in the chat that are precisely along those lines. Moni McGee on, materials that will help her pull together a few lectures in a graduate class on this. And also then Thomas has sort of followed up about asking about, software packages that at least help analyze whether or not you'll be doing a decent job. Yeah.
So, so for the teaching aspect, so again, this is what happens when you don't have a lot of people and then you complain about it and you're like, well, I can't complain about it as long as I'm trying to do something about it. So at Urban Institute, we've taught how the basics of data privacy and confidentiality along with synthetic data and differential privacy, because those two are like the most popular things right now. And so they're actually available online on a GitHub website. We did one for some trainings for what's called Allegheny County, which is where Pittsburgh, Pennsylvania is in. We did one for JSM. We did a full day course on it, but with some more focus on, again, differential privacy, because that was what people asked for. We also did a half-day course for the Women's Statistics Data Science Conference. I'm just going to put this out in the void. I have submitted a proposal to try to take our trainings, but make them fully modularized and actually make a recommended curricula, because these courses and trainings that we've provided, sometimes they're focused on the concept, sometimes they're focused on the coding. So there's always like, if we do coding, we accompany it with our code on like how to like generate maybe the basic synthetic data or get people to walk through it or like fill in the blank. But it would be nice to, if we could modularize it and then have like a recommended, like, if you want this kind of learning objective, these are the modules I would put together. Putting that in the void because we still haven't gotten funded to do this. I would love to actually do that, to make that resource available. I believe Monica, who has like a page on her website when she talks about like how she would approach teaching it. I know she also is trying to find time and funding to do this too, but like we can only do so much. So I know that she's looking into it as well.
Wonderful. And so the follow-up question is just on software packages. And I think Thomas here is not necessarily asking so much as about implementing differential privacy, as assessing how successful that's been.
Okay, so for software, I think the most popular one that people will think about is called SynthPop, from out of Edinburgh. It's like Gillian and Chris who worked on this, and it's great. It's based on base R, is the drawback. So I will say at Urban, we are developing code. We are slated to fully publish it by the end, I think, of end of 2024 or early 2025 to be on CRAN. So that's our goal. We're like steaming ahead, trying to get it out, which is generating synthetic data with R, but it's in the tidy like models framework. And so we're trying to get that out. It was used to synthesize the taxpayer data. We used it to synthesize health data for Allegheny County. We're going to be using it to synthesize what's called the survey of earned doctorates in the United States. So like if you get a PhD in the United States, you fill out a form. It's kind of a pain, but you say, I will do anything in order to get my doctorate. So we're doing that for the National Science Foundation. So that's what I'm putting out the void. Those are like the main ones. There are some proprietary, or I should say proprietary. There are some proprietary software out there, but we're going to ignore those. There's a place called OpenDP that's under Harvard group, or started by a Harvard group, to create some code to do what's called more differential private methods. I think it's in Rust, Python, and I think they're trying to get it into R as well. So those are kind of software outlets you can do. But again, it's like, that's not very many considering, like I said, we need more, right? And you imagine like other methods like causal inference or like some biostat methods. Like there's so many different just packages in R, let alone the other languages too. So what I just said was really limited. I saw another question, or do you want to ask? Oh yeah, you should say.
Go
it.
ahead. So there's a question on sort of randomized responses. Is this a statistical disclosure control? Is this differential privacy? And I'm wondering, personally, reading off that, should we be actually thinking of this as differential privacy as a definition and statistical disclosure control as a set of techniques?
Yeah. So I think of them as like the full umbrella of like all the different methods. First off, so randomized response, it's kind of, I always say it's kind of dual in this case. So I'm glad that Thomas brought this up. So randomized response would fall from the traditional methods initially, but there is a version of differential privacy or formal privacy that's called local differential privacy. Now, I'm going to back up right here and say that there's different ways you can release differentially private or formally private like information. You could do it through a query, or like what's called like, or actually backing up, ignore the query part. Say that's a trusted curated model. There you go. It's where the curator is trusted to gather the information and say, hey, I'm going to release some statistics or queries, or answer your queries, or I'm going to release a data set. So that's the thing that I was focused on. That's very traditional. That makes a lot of sense. The other one is like, you do not trust the curator at all. They cannot be trusted. So that's where randomized response comes in. And then there was a paper that proposed what's called local differential privacy, where in order for like when the data gets collected to the curator, it gets randomly changed, and using what Thomas pointed out, which is like looking at Laplace noise. There's that. There's also there's a paper that did Gaussian noise to do that. There is a big downside by doing a local differential privacy kind of approach, which is you're going to naturally break the relationships from the people that you collect information from. So there was actually a paper done using local differential privacy to create a social network data set where they were just looking at the edges. So there's a probability of like there being a edge or not edge between two people in a network, or like relationship between the two networks. They randomize whether or not that's going to be like present or not. And so it's a way to perfectly protect this social network, but you can imagine it just broke a lot of the relationships. So like in social network, they talk about like how many triangles get preserved, how many like distances from like one node to another is preserved, things like that. That all gets broken if you use a local privacy approach.
Thank you. I think we're close to time. I'm going to finish up with one of my own from a higher level, because I know you work in a lot of policy spaces as well. There's been a lot of interest in sort of machine learning AI regulation recently, and I've seen a lot of pushback about saying, look, you're not going to manage to make one size fits all regulations. You really are going to have to do this sort of on a use case by use case basis. is privacy in that realm? Are there things that we can generally say that aren't just motherhood? You know, is there something useful to do regulation-wise?
Yeah, okay. So I love that you brought up this question, because this is something I'm actually working on with another project, where they're like, hey, we need to figure out a framework for data access. And how would you do disclosure review for this? And I was like, okay, again, if I was in an idealized world, I would make a column of like, this is at the minimum you need to consider. Like, definitely de-identify the information. You cannot report social security numbers, names, and things like that. You can't have like so few people because the sample size is too small and things like that. But then there's like this other column of like maybe some recommendations and consideration or caveats, because it does depend on the data. Like some data are just naturally way more sensitive than others, and so you have to go through more of a formal process of like interacting with people, making sure you're preserving the right information, or even to the point of like, I think with one example, sorry, we're going over, but there's another one where I was talking to the American Bar Association. So that's like the exam in the United States to be able to practice law in certain areas of the country. And so this council on data equity, we're trying to think about like, we would love to publish information about people who are LGBTQ, who are going to certain universities, and being able to flag that this program in the United States is really friendly towards those who identify as LGBTQ plus. But maybe there's some individuals who says, hey, I don't want people to know I'm transgender. Like, do not record me at all. And so that goes into like this whole like asterisk area of like, do you do it by case basis of like, maybe do report this university statistics on that, because the people have opted in saying like, yeah, I'm okay with my information being disclosed, versus like another place saying no. So that is something that they've been considering about, because they want to be more inclusive, but then there's all these sensitivities going on too. So it's a hard problem.
Awesome. Well, thank you so much for telling us about it. Thanks to everybody who joined us. We will put the recording of this webinar up on the Statistical Computing YouTube channel as well, and we'll send a link out to all the registrants for that as well, if you want to come and look back at a great recording. Thank you so much, Claire.
Thank you, everybody, for all the great questions, and I hope you enjoyed the talk.
Thank you.